Well, good morning. I'd like to call the Subcommittee on Digital Commerce and Consumer Protection to order. The chair now recognizes himself for 5 minutes for an opening statement. And again, good morning and welcome to the first Disruptor Series hearing in 2018. Today, we're continuing the subcommittee's efforts to examine new and innovative technologies while learning directly from companies about what opportunities they see 5 to 10 years in the future. I'd like to thank all of our witnesses for being with us today and highlight that OwensIllinois is headquartered in my district in Perrysburg, Ohio, and we've held 2 roundtables on IoT and cybersecurity issues with local businesses at your headquarters, and I appreciate that. Last summer, this subcommittee hosted a showcase with IoT companies from many of our member districts. We also held a hearing about how the IoT and interconnected network of physical objects embedded with sensors and communication devices that exchange information can improve productivity, increase response times, drive down costs, and benefit consumers. Today, we'll discuss how IoT is making American manufacturing more competitive and how innovation is improving the lives of Americans. We'll also learn about barriers to the continued expansion of IoT and what policymakers should keep in mind as the use of IoT expands. The ability of devices to communicate with other devices is revolutionizing industrial practices both in the United States and abroad. Already, there are examples of smart components sending data about their performance and condition to workers who can monitor the equipment and, if necessary, replace it before it breaks down. Municipal water systems embedded with sensors can relay information about blockages or leaks that will help ensure that the water keeps flowing. Another example is how electricity providers can monitor electrical grids embedded with sensors and relays that can identify outages or surges, locate alternative pathways, and ensure that electrons keep flowing. Looking forward, the potential to further improve manufacturing processes through the combination of new technologies stretches the imagination. Utilizing IoT and other emerging technologies like augmented reality, workers will be able to virtually make adjustments to industrial systems to understand how to improve efficiency and then implement necessary changes without interrupting the manufacturing processes. IoT-connected factories will be able to monitor their need for raw materials and then order those materials from IoT-connected warehouses. IoT-connected transportation service providers will then deliver necessary products without the intervention of a human. These and other opportunities allow IoT-connected manufacturing centers the ability to devise their own ways to run more smoothly. The expansion of smart industrial processes will continue to create historic changes in how American companies build and deliver products. More efficient factories means that consumers will have more choices for the goods they purchase while being able to obtain them at a lower cost. At the same time, like all new technologies, IoT will create disruption in the manufacturing economy. This disruption will create the need for new ways of educating and preparing our workforce both now and in the future. In addition, cybersecurity issues will remain an ever-present concern for an internet-connected service, and the IoT is no different. Constant vigilance and improved coordination will be required to ensure that bad actors don't take advantage of the weaknesses in IT security policies. Today, we look forward to our witnesses describing how IoT is being leveraged in their facilities to improve manufacturing processes, how to address concerns around cybersecurity, how this technology is likely to develop in the future, and what policymakers can do to help promote continued innovation in American manufacturing. And with that, I will yield back the balance of my time and now recognize the gentlelady from Illinois, the ranking member of the subcommittee, for 5 minutes for an opening statement.
Thank you, Mr. Chairman. The Internet of Things, of course, has tremendous potential to change manufacturing in the United States. Smart manufacturing can help businesses save resources, improve performance, and expand consumer choice. For example, a senior can remove the need for a human worker to physically check a machine. I didn't mean a senior, I meant a sensor. A sensor can remove the need for a human worker to physically check a machine, assuming everything works correctly. That sensor makes the worker's job easier and reduces the opportunity for human error. As the Internet of Things evolves, even more and more processes can be automated, And this raises some familiar issues for subcommittee, familiar issues for subcommittee: privacy, cybersecurity, safety, and labor market impacts. Advanced manufacturing requires a different set of skills than the production line of previous generations, and workers must be trained for these jobs. And we need to be responsive to the needs of workers who may be displaced by changes in manufacturing. We must also be mindful of accessibility. I think back to the autonomous vehicle legislation that the House passed last year that this committee worked on. Self-driving cars promise to open up new opportunities to those with disabilities. That's great, but some of those vehicles need to be accessible for people in wheelchairs, for instance, so that we can fully realize the potential to improve mobility. The same goes for manufacturing workers. Depending on how the technology is designed and integrated, bringing the Internet of Things into manufacturing could either expand or limit job opportunities for those, for example, with visual impairments or physical disabilities. In addition, we must ensure that businesses can get the full benefit of smart manufacturing. Often, a prerequisite for businesses to integrate new technologies is the broadband to support it. Last year, Democrats on the Energy and Commerce Committee unveiled a comprehensive infrastructure package, the Lift America Act, which included a $40 billion investment in secure and reliable broadband. A serious infrastructure bill takes real dollars, and I hope that we can work together to advance that type of job-creating legislation. I would also note that some of the advances we see in the manufacturing stem from research supported by the federal government. For example, President Obama established a national network for manufacturing innovation, which included the Digital Manufacturing and Design Innovation Institute in Chicago, which I have visited. The Trump budget eliminates funding for the manufacturing institutes. The U.S. can only lead in research if we invest in research. We need a bipartisan deal to raise the budget caps on both the defense and non-defense side so that important investments in infrastructure and innovation can continue. I thank you, and I yield back. Unless there's anybody who wants my remaining time. Okay, I yield back. Thank you.
Thank you very much. The gentlelady yields back. The chairman of the full committee has not arrived yet, but is there anyone on the Republican side wishing to claim that time? Not hearing anyone. The chair now recognizes the ranking member of the full committee, the gentleman from New Jersey, for 5 minutes.
Thank you, Mr. Chairman. Since 2015, this subcommittee has been examining the opportunities and challenges of the Internet of Things, from autonomous vehicles to wearable technology. But the Internet of Things extends beyond consumer products. It can be found across industries, including in the energy, healthcare, and transportation sectors. And today we'll discuss how it can help make manufacturing more efficient, more productive, and more safe. The Internet of Things is used in smart manufacturing to make real-time control of production possible. Companies report that using smart manufacturing technologies lowers their energy use, reduces waste, improves product quality, and saves money. And with more efficient manufacturing, we see less pollution, fewer health issues for our workforce, and more opportunities for good technology-based jobs. As with all connected technologies, strong cybersecurity is essential to successful smart manufacturing. While the Internet of Things helps ensure that a manufacturer's monitoring, measuring, and sensing control systems work together, one weak point can affect the whole network. Imagine the potential consequences if a malicious actor brought down automated manufacturing at a pharmaceutical plant that makes vaccines, or if network disruptions affected quality control monitoring for seatbelts at an auto plant. Experts have found that companies in the U.S. are not doing enough to address these risks, and that strong, comprehensive framework for cybersecurity and manufacturing is urgently needed. And also, unlike our smartphones, which seem to be replaced every few years, large machinery is used for decades, adding to the difficulty of ensuring they are consistently and properly updated for security vulnerabilities. And I've said at previous hearings on automation that we should not be scared of these new technologies, but we must realize their potential effect on jobs. To stay competitive, we must ensure that employees are prepared for the changing workplace, and we need to invest more in research and development so that the U.S. continues to lead the world in innovation. For years, we've listened to experienced witnesses in industry, academia, and government tell us that federal investment is vital if we want to keep making things in America. Unfortunately, the Trump administration proposed a budget last year that eliminates dozens of essential, successful programs that make manufacturing innovation possible and provide support for U.S. factory workers. Moreover, industry witnesses repeatedly tell us what they really need is stability, yet Republicans have repeatedly failed to pass final appropriation bills for the fiscal year that began on October 1st. And we're once again at a deadline tomorrow. It appears that Republicans are going to try once again to kick the can down the road. And with this delay, Republicans are adding even more instability, ultimately hurting American manufacturers and workers. I think those delays must end, but we'll see. And I'd like to yield the remainder of my time to the gentleman from California.
Thank you, Ranking Member Pallone. The Internet of Things and the Industrial Internet of Things represents a shift in how companies and manufacturers interact with data. Smart manufacturing enables real-time monitoring and tracking of a company's assets through the manufacturing process. New technologies and tools can be critical to the means of facilitating the efficiencies promised by Industry 4.0. Of course, connectivity is a cornerstone of the next industrial revolution, and wireless connectivity depends on the availability of spectrum. I believe that technologies like blockchain could play an interesting role in both spectrum sharing to potentially maximize the efficient use of spectrum bands and as a means of tracking digital records in real time. Thank you, and I look forward to the witnesses. And I yield back.
And now yield back, Mr. Chairman.
Thank you very much. The gentleman yields back the balance of his time. This concludes member opening statements. The chair reminds members that pursuant to committee rules, all members' opening statements will be made part of the record. Again, I want to thank all of our witnesses for being with us today. We appreciate you taking time to testify before us, and it's very important to hear from you and your testimony. Today's witnesses will have the opportunity to give 5-minute opening statements, followed by a round of questions from the members. Our witness panel for today's hearing will include Mr. Rodney Nazmi, the Vice President of Technology, Service Delivery Information Technology at OwensIllinois, Mr. Thomas Ben-Cully, Chief Technology Officer at Zebra Technologies Corporation, Dr. Thomas R. Kerfus, Professor, and Husco Ramirez, Distinguished Chair in Fluid Power and Motion Control at the George W. Woodruff School of Mechanical Engineering at Georgia Institute of Technology, and Mr. Sanjay Pune, the Chief Operating Officer at VMware. So we greatly appreciate you all being with us today, and Mr. Nazmi, you are recognized for your opening statement for 5 minutes. Thanks again for being with us.
Good morning to the members of the committee and to my colleagues who've traveled to Washington today to discuss the importance of the Internet of Things. Before I begin, I'd like to thank Congressman Latta for his continued leadership and engagement on the issue. I also want to thank the committee for the opportunity to discuss IoT, which is important to U.S. manufacturing and my company specifically. OwensIllinois, headquartered in Perrysburg, Ohio, is the world's largest manufacturer of glass containers, serving globally recognized brands throughout the world. Our company operates 79 manufacturing plants throughout the world, 17 of which are located in the United States. Glassmaking has historically been a trade where craftsmen, craftspersons, and apprentices would develop expertise in the art of glassmaking. At the turn of the century, Michael Owens invented automated glass manufacturing, which was a huge step change in productivity and worker safety. While the glass-making process is highly automated today, the industry is poised for the next step change, which will come from the factory becoming increasingly connected with IoT technologies throughout the end-to-end process. The information collected through IoT technology will be used to transform the craft of glassmaking to that of data-driven science, which will enhance the competitive position of glass in the global packaging industry. Glass containers are the most sustainable option in the competitive packaging landscape, with a life cycle that goes from cradle to cradle, reusable in many markets, and infinitely recyclable into either new glass containers or other products. Glass is truly the sustainable packaging option. OwensIllinois is on an IoT journey which will transform our manufacturing process and add value to the products and services that we sell our customers. There are several IoT areas of focus for OI. Improve manufacturing performance through higher yields, increased quality, and reduced costs. IoT will deliver deeper insights into our end-to-end manufacturing process. The data generated from sensors in the plant will provide insights into environmental conditions, process settings, and control variances, enhancing our ability to increase first-time yields and improve quality. This work will require skilled engineers, information technology professionals, and data scientists. The data acquired through IoT will be used to reduce reaction time in the plants and allow us to adjust the process if controls are slipping out of tolerance. Addressing the variations in manufacturing process will be realized in a more proactive manner. The IoT platform will transform glass making, the glass manufacturing process from one of reactivity to one that is proactive and highly automated. The information generated by new sensor technology, data science, and information automation will increase yields and improve quality while achieving reduced costs and enhancing OI's ability to compete in the U.S. and global markets. Energy management and predictive maintenance are the second area of IoT development OI is pursuing. It takes a great deal of energy to melt and form glass and to operate a glass container manufacturing facility. Developing sensor technology can help glass containers maintain the status of the most sustainable packaging solution and reduce energy used to operate our furnaces. Advanced sensor technologies can also be used to collect information while monitoring equipment throughout the manufacturing facility and could be critical to seeking new ways to maintain equipment. IoT technologies and the concepts around IoT is enabling OI to also create and develop new and differentiated products and services for our customers with the goal to ensure the integrity, safety, and authenticity of its contents. I would like to highlight several concerns regarding successful deployment and sustainability of IoT. The cost to achieve a full deployment of IoT throughout an enterprise can be quite daunting. A successful deployment of IoT requires sensors, PLCs, IT systems, networking, massive amounts of storage, and software to achieve the desired business outcomes. Seeking ways to make these investments more affordable can be a way to help U.S. manufacturing accelerate its investments in IoT technologies. Protecting against cybersecurity risks will become more critical while manufacturers deploy IoT in facilities. Manufacturing equipment, devices, sensors, and control systems that previously may have been standalone may be exposed not just within a plant location, but also potentially throughout an enterprise. Cybersecurity-related disruptions could cause unplanned downtime or impair productivity. Cybersecurity attacks could also put health and safety of employees at risk. Data scientists are in short supply and high demand. Transformation of the workforce becomes more critical. Tomorrow's manufacturing workforce must be increasingly knowledgeable about the use of information technology. Engineering disciplines and information technology skills will be needed to deliver and sustain these solutions. The use of business intelligence, analytics, and the role of data scientists will be critical to the success of IoT. In conclusion, as manufacturers continue on the IoT journey, Congress may want to look at into the following ways to help foster growth of IoT technology and its use. Assist manufacturers in making IoT technologies more affordable by encouraging research and investment in these capabilities, or in programs which encourage manufacturing companies to deploy IoT. Support programs and resources that address cybersecurity in U.S. businesses, and encourage more research in the IoT data science discipline, and seek ways to encourage a supporting pipeline of skilled workers through universities and manufacturing-related technical schools. Thank you for your time and attention.
Well, thank you very much. And Mr. Bencali, you are recognized for 5 minutes. Thank you very much for being with us.
Thank you, Chairman Lotta. Ranking Member Schakowsky, and members of the subcommittee for the opportunity to testify before you today. I'm Thomas B. Cooley, the Chief Technology Officer of Zebra Technologies Corporation, and we're a global leader in bringing Internet of Things solutions to business and business to government markets. With approximately $3.7 billion in revenue, nearly 7,000 employees, and doing business in more than 40 countries, Zebra is a trusted partner to more than 95% of all Fortune 500 companies. And while many Americans may not know us by name, I'm sure they come into contact with our solutions every day. For example, the barcode labels that are printed and applied to airline baggage tags or express delivery packages and pharmaceutical prescription bottles are often generated by a Zebra barcode label printer and tracked and managed by Zebra barcode scanning technology and mobile computers. Similarly, manufacturing, warehouse, and delivery workers, as well as countless healthcare workers across the globe, employ our mobile computing devices in their daily work to increase efficiency, reduce errors, and drive a better customer experience. Overall, what we see in the marketplace every day tells us that manufacturers and their supply chain partners are increasingly recognizing the transformational role of industrial IoT. Solutions in driving growth and improving performance in several key areas of business activity, including increased total production and throughput, improved ability to adjust to fluctuating market demand, an increased ability to produce a greater number of product variants, an increased visibility into operations across a given business enterprise, and a decreasing cost of production. All of these advances reflect the fact that at its heart, the IoT revolution is a dramatic change and advancement in the way companies capture and ultimately share data. The ability to have data about inventory that's immediately available to both plant floor managers and suppliers is providing new levels of visibility that heightens operational performance, and from the greater visibility comes the great advances we're seeing in manufacturing across a wide array of industries. In the opening comments from Chairman Latta, I heard mention of augmented reality and wearable technology. I think we should really keep that in mind as we see the industrial Internet of Things creating more and more data. There's the opportunity to collect that data, analyze that data, and then use that information to inform a worker. And as we're starting to see that occur, we're seeing the mobile and computing technologies migrate from an interface that is handheld to interfaces that become heads up and are able to augment our physical reality with digital information that helps U.S. citizens and U.S. workers just get the job done. And I think that's an incredible opportunity for competitive advantage for us to help drive efficiency and to lead the world by way of example in that regard. Whirlpool Corporation wanted to optimize mobile device management at its distribution centers as a way of enhancing productivity. They were experiencing problems with misplaced devices, battery life, the inability to update devices in a systemic way, and a lack of data metrics around device performance. They needed a centralized management system to track device health, productivity, location, and ensure proper deployment. To solve their problem, Zebra worked with Whirlpool to employ an IoT-based solution which uses our mobile computers connected to their vehicle mount computers and their handheld devices. We connected all of their devices back to the cloud across all of their facilities. We're able to manage predictively detect when batteries may need replacing, when the performance and health of applications on the device, the resiliency and security of the network, and by monitoring all that information in near real time, we can detect and proactively intercede if we see that a device is going to have a problem, thereby driving up the overall worker efficiency and uptime of their operations. Congress can play an important role in helping to ensure that all companies across America can successfully employ industrial IoT-based solutions. Specifically, we urge you and your colleagues to support infrastructure legislation that promotes the deployment of mobile broadband networks, as well as directs the NTIA and FCC to allocate more commercial licensed and unlicensed spectrum in a technology-neutral way. Additionally, we urge Congress to advance policies that will help assure coordination among government agencies so that regulation of IoT does not needlessly impede innovation. In sum, Mr. Chairman, we commend the subcommittee for holding this hearing, for your ongoing efforts to ensure that American industry has the ability to continue to roll out new technologies that will improve the lives of both our workers and our citizens. IoT presents a transformative opportunity, some calling it the fourth industrial revolution, the advent of cyber-physical systems that will create all types and sizes of opportunity for jobs of all types and sizes across the United States to work smarter, be more productive, and help improve the overall American economy. At Zebra, we're committed to bringing IoT solutions to companies to help them achieve their goals. We look forward to continuing to work with the subcommittee, and I thank you for the opportunity to share Zebra's story, and I'm happy to answer any questions you and your colleagues may have. Thank you.
Thank you very much. And Dr. Kerfis, you are recognized for 5 minutes. Thank you.
Thank you, Chairman Latta. Vice Chairman Kinzinger, Ranking Member Schakowsky, and other members of the committee, I do appreciate the opportunity to testify here before the subcommittee. So I'm Tom Kerfis. I'm at Georgia Tech. The difference between my colleagues here and myself is our product are our students. For example, mechanical engineering produces about 3 to 4% of all the mechanical engineers in the nation. And these kids are extremely capable and really moving a lot of the IoT forward. I have spent a lot of time in manufacturing. I grew up actually in a plant in Congresswoman Schakowsky's district, went to high school there and so forth, a small family plant. So I've been in production for over 40 years. And if you look at it, we talk about the fact that, yes, it's going to take a lot of money to censor up, as we would say it, but there are already a lot of sensors out there, and they're providing free information, to us and so forth. So there are a lot of sensors. They're generating big data. The companies know this, and we're starting to track this. My team works with 2 major U.S. OEMs in automotive, a major OEM in aerospace, and several large-scale suppliers to figure out what their digital manufacturing platforms need to look like. And basically, all the data are there for the taking, and how are we going to make use of them, right? And then the question is, what can we do with it? Well, certainly we can improve efficiency. I think we've heard about that. We can lower our energy consumption. We can lower our waste. This is very clear. It's been demonstrated time and time again. I've spent a lot of time actually over at the BMW plant in South Carolina. Tremendous opportunities there in terms of moving it forward. A safer workplace. Certainly the more sensors you have out there, you know what's going on. You can make sure that your employees are safe, right? And you can make sure that those machines keep them safe and actually make their jobs easier and more reliable. But perhaps a very important point that we need to really understand is that this capability allows us to respond rapidly to the changing markets and the changing technologies that are out there. And those technologies and markets are changing rapidly. It took about 70 years for the telephone to become ubiquitous. It took about 10 years for the mobile phone to become ubiquitous. It took about a year for the smartphone to become ubiquitous. This is how fast things are changing. So we can have a safer place, a place that responds better, and what industry doesn't want to respond better and faster? What do we get out of the Internet of Things for manufacturing? First of all, there are better paying jobs. There's no doubt about it. But I will caution you, and I'll say this again, it requires a much more skilled workforce and a better trained workforce. But it's not impossible to do. I think we just saw it over here, and I'll wave mine around too. People are used to the smartphone. This is not something that they're afraid of. We can get them to use it, and actually we're using smartphones in production operations day in and day out at a number of different corporations. We get a stronger, more productive manufacturing base, which is always good for the nation's economy and national security. And we basically excel in the strengths of the culture of the United States of America. We are innovative, all right? We have some of the best ideas, and what this technology allows us to do, IoT for MFG as we call it, it allows us to get these ideas out there rapidly, and not just out there, but to scale them in terms of the market. And you know what? Somebody else wants to copy us? Come get us, because by the time you copy us, we'll have our next technologies out there, and we can see how fast these things are moving along. So how do we get there? Basically, we have to look at workforce development. I heard cybersecurity a number of times. This is critical. People have, and we've actually seen in companies where they say, no, we're going to do this because of cybersecurity issues. They have now come to the realization that we have to do this if you're going to compete. And we're looking at cybersecurity. We have a lot of, for example, national labs. NIST is doing some great work in cybersecurity analysis and so forth in conjunction with our universities and a variety of companies. So it's there, we're thinking about it, we're working on it, and we're beating the bad guys in most cases. We have to develop that infrastructure to make sure that that broadband connectivity, I heard that, right? That is so important. Again, the low-cost labor areas, yes, you see there's shiny new factories, but a lot of the low-cost labor areas don't have that type of connectivity. We can leverage that, we could make use of that, that is where we can compete. We also need to take a look at our universities, right? How do we leverage our universities? How do we leverage our national labs? places like NIST, and bring them together. I heard the National Network for Manufacturing Innovation, Manufacturing USA. This is where companies are coming together to really move things forward for the United States of America, and this is where we can really leverage these things. So basically, this is going to allow us to rapidly address a changing market, not just what people want, but what the technology is when it comes out there. The bottom line is IoT for manufacturing, it's going to grow. It's going to grow high-end jobs, but that basically means not just workforce development, workforce training, not training the next generation workforce, but training the current generation workforce. It can be done. We can't compete on the low-end jobs. We just can't, right? But we can compete on the high-end jobs, and people are not afraid of the technology. It is amazing. You know, we're doing Pokemon out in the factories right now, and they're tracking things, and they love it, okay? And their reward might be to get off a couple of hours early on a Friday afternoon. But it allows us to grow the national economy, to grow key sectors of the national economy, high-tech sectors, to strengthen our national security, to make sure that we are able to move forward in a rapid and nimble way. Thank you very much.
Again, thank you for your testimony. Mr. Pune, you are recognized for 5 minutes for your opening statement. Am I pronouncing your name correctly, sir? Thank you.
Dear Chairman Lata, Ranking Member Chakowski, members of the subcommittee, and my honored colleagues from academia and the industry. It's an honor to be here to testify in front of this committee. And by way of introduction, my name is Sanjay Pune. I'm Chief Operating Officer of VMware. VMware is one of the top 5 software companies in the world, about a $54 billion market cap company. We're headquartered in Silicon Valley in Palo Alto. We're also part of the Dell Technologies family. It's very clear from a lot of what you've heard already that Internet of Things and IoT is going to have profound impact on the consumer economy and also in the industrial age. I'll just give you 2 examples of how our lives have changed. One is from my past job. I worked for a German software company, SAP, and many of the meetings that I had would actually be at 1 p.m. in the afternoon German time, which is 5 a.m. Pacific time. So the meeting's scheduled. I go down to my home office, and I find out that overnight some person had the great joy of canceling the meeting. Now, listen, wouldn't it have been nice if I could have known that before I went to bed, and I could have probably woken up an extra hour later? It would be nice if, once the meeting is canceled, it actually communicated with my alarm clock that actually set my clock up an hour later, which is very much possible today with IoT, because often the alarm clock and your calendar is on the same device. Another example, when I leave to go to ski, not a lot of snow this year in Tahoe, but in the years that we do have snow, we'll have a debate with my wife as to whether we turn the heating off. And I like to keep the energy down and keep the house not necessarily heated all the time. She wants to keep the house warm for our kids when we come back home. Well, now with modern thermostats, you can actually turn your thermostat on or off from your phone when you get about an hour closer. Nest and many others are doing this. So this is the practical way in which our consumer lives are being transformed for the better with IoT, and this is now starting to invade the American worker. And manufacturing actually becomes enormously smart, as you've heard, because of this, and has profound impact, we believe, in lots of new areas, artificial intelligence, big data, machine learning, that can be very positive, as opposed to much of what's also been talked about, the negative impacts. But it does have some profound security challenges, and that's been a key part of VMware's focus. VMware's focus is to ensure that the cyber attacks that we've seen, whether it's WannaCry, Petra, many of these things that could get even more profoundly disruptive in the context of IoT, is something that we can attack and we can protect ourselves from. So we've actually been focused on aspects of cybersecurity and cyber hygiene that allow companies to protect themselves in this era of IoT. We've got some very practical ways in which management security could be baked into the infrastructure of both technology and manufacturing. We think that everybody today, whether you're in technology or not in technology, need to be educated in some very fundamental principles of security. Like, for example, least privilege, microsegmentation, multi-factor authentication and identity management, encryption, patching. These are all very fundamental concepts that board members today are being educated on, and certainly government and other professionals need to. As we think about the notion of hardware, that's also getting more sophisticated. We heard about mobile devices and rugged devices with one of my colleagues. Edge gateways now are becoming ways by which this miniature data center could actually become micro into something like a little nano data center, protected and ready for the production line. These are the ways in which we believe that the Internet of Things and smart manufacturing can actually be secure. In closing, the Internet of Things will have a significant and positive impact, we believe, on both American innovation and jobs. Billions of IoT devices will be in the free market for consumers, will be available to manufacturing, and could have a very positive impact. But to make sure that this is actually deployed in a safe fashion, security is key. If consumers are to trust these devices and manufacturers were to trust these devices, we've got to take security seriously, and we believe that this is something that both the coming together of academia, of industry, and the government makes this a priority. We look forward to working and doing our part at VMware to make this happen. The other aspect of this that could be very positive is the way in which the data can actually help a whole new category of jobs, whether it's machine learning, big data, artificial intelligence. This is going to be the next caller of jobs. And much the same way that in the agrarian culture 100 years ago, we couldn't see the coming of computing and high tech, the same way the next 50 to 100 years are going to be very exciting in terms of new jobs. Chairman Latta, Ranking Member Chakowski, I applaud the leadership of this committee for holding this hearing today. Thank you for the opportunity to testify, and I look forward to answering the committee's questions.
Well, again, thank you all for being with us today. We greatly appreciate your testimony before the subcommittee. And now we'll move into our question and answer portion of the hearing. And I will recognize myself for 5 minutes. Mr. Nazmi, what are the major advantages for OI that come from using IoT? And again, when I've been through the facility in Perrysburg, where you do a lot of the testing and seen a lot of what you're implementing here, but if you could maybe just walk us through what you're doing.
Certainly, some of the advantages are increased productivity in our manufacturing facilities. As I said in my statement, glass is still somewhat art, and we need to transform to data-driven science manufacturing process where we can increase our yields. Glass manufacturing today, a yield is somewhere in the 90 to 91% yield rate. If we're able to do that, we're able to unlock potential and capacity out of our factories and better serve the markets and ultimately reduce our cost to our customers.
You know, what are some of the challenges that you're facing out there today in the whole manufacturing process then?
And having enough of knowledge base in a workforce that has a demographic that is changing. The generation of knowing what to do, when to do it is changing in our organization, and being able to empower people with information so that they can react faster and more nimbly is incredibly important. And cybersecurity, that is a concern today because many of our machines and equipment stand alone, so they're not exposed to cyber attack. And as we network them and collect more and more information to better empower our workforce, it's going to be incredibly important that we protect the floor, our people, and the company.
Well, thank you very much. Mr. Ben Cooley, can you give us an example of how a sensor can be used to convert data from a format that allows companies to improve manufacturing efficiency?
Sure. I think a couple examples there. One is just driving the operational efficiency. I mentioned the Whirlpool example earlier, where we just have a stream of data coming from devices. Well, just like we've done that with Whirlpool on device health, we're looking at doing that with the entire manufacturing facility. So imagine, if you will, a smart manufacturing environment. We know where goods are, we know where the capital assets are in that environment, we can know where people are located, and we can bring the intersection of all those things together in an optimized way. If we think about our daily lives using a route navigation GPS system in our vehicles, the incredible amount of advantage, the ability to dynamically reroute based on weather and traffic in real time. And think about going from outside the four walls to an inside the four walls factory environment and being able to bring that same level of route optimization, workflow efficiency, dynamic workflow optimization to the processes by instrumenting the environment. I think that as we look at data coming from these environments, we're moving towards a world where we no longer operate on what we think is happening. Where do I think my people are? Where do I think my assets are? What do I think inventory is? We're operating in a world where we truly know that in real time. And so we're able to close this gap between what we think is happening and what we'd ideally like to be happening. And that is where the benefit is, the efficiency benefit, the return on investment is being able to close that gap. And so you can run your operations in a much more precision way and in a way that's optimized from the get-go. We're seeing the need, the imperative to do that because of the on-demand economy. The notion that products and services are being delivered ever closer to the point of demand is a reality. We order online, and the expectation is that product or good or service is delivered sometimes in an hour to our doorstep if it's a package that we ordered online and we live in an urban city. Or in some cases, I'm standing on a street corner and I request a ride, and in moments I expect that to show up. So the production and provisioning of products and services ever closer to the point of demand mandates, it's an imperative that we have IoT solutions that are able to create real-time streams of data to enable that new reality and propel us forward. Thank you.
Thank you. Mr. Pune, I guess in my last 40 seconds, this is going to be quick. Excuse me. This deals with how do manufacturers manage the threat of cyber attack disrupting their operations? Excuse me.
Okay, good. Yeah, I think one of the things that we have learned, Chairman, sir, is that in this world of mobile, this device is now sort of the remote control to your life. We've learned a lot about security in the last 10 years with the mobile device. These operating systems have adapted themselves from the PC era to have even greater level of security, whether it's Apple iPhones or Android devices, some of the security things that we heard and saw in the early days of Windows. And even the PC operating systems, latest versions of Windows 10, are better at being able to do it. So we expect that same innovation, and this country has got some of the best research, whether it's from academia or other places, will continue to be poured into the operating systems that run on these IoT devices. That's one, and we expect that to just have a greater and greater level of enterprise hardening. Secondly, the devices and the systems that they talk to, whether it's the data center or the cloud, will have the types of things that I talked about, cybersecurity, security infrastructure baked into it that have the types of things like segmentation, multi-factor authentication, encryption. And we're learning from all of the attacks that have happened to make those also systems hardened. And then the third and final thing is just basic hygiene. It's sort of just like you have a good diet, you do your exercise, you still got to have certain hygiene principles, brushing your teeth, taking a shower, things of those kinds. We've got to educate government, industry, academia, college students so that as they approach the workforce, there's simple things you probably want to do. You may not want to send your password, for example, in clear text in a text message. These are the types of things that, and you may want to change your password. These are the types of things that I think are very easy for us to continue to educate that make us all a much more secure society and a secure infrastructure for IoT.
Thank you very much. And the chair recognizes the gentlelady from Illinois, the ranking member of the subcommittee, for 5 minutes.
Thank you. First, Owens, Illinois. Are you still in Illinois at all?
Yes, we are. We're in Streator, Illinois.
Okay. I'm glad to hear that, being from the Chicago area. I think years ago, saw the plant. Were you ever in Granite City, down in the southern Illinois? No. Okay. Let me ask Dr. Kurfus some questions. How do workers in manufacturing stand to benefit from the adoption of these technologies? Can the IoT be used to, for example, positive things, prevent workplace injuries, limit workers' exposure to hazardous materials, et cetera? I mean, what are some of the pluses, IoT for workers?
Sure, it's a great question. There are a variety of things that can be going on. For example, worker going through the factory. If you've been, for example, to an automotive factory, you see the robots going on. They're moving, they're working. These are carrying sometimes thousands of pounds. So they're very powerful robots, and you never let a human get close to them. But now you have the robot area, you have the human area, and the reality is now with IoT of things, and again, one has to be careful about, this issue of privacy and so forth, but I'm even walking down with my phone. I know where people are, so if somebody walks into an incorrect area, we can shut it down and make sure the robot, doesn't, hurt them, but even better, we can start to localize it better. It's a much tighter resolution, such that the robots can be working with the people. Robots are great, but they're never going to replace people completely. I mean, they're great at lifting really heavy things, but try and pick up an egg with one and so forth. We had great research on that, but again, working together is really where you leverage it. And by the way, it also allows us to get rid of a lot of the really nasty jobs. Your statement about taking away the sort of the terrible jobs, checking coolant tanks and lubrication tanks and machines. That's all automated. In fact, I was smiling. I was down in your cafeteria, and I saw your coffee containers, the coffee urns. They have the same technology that we're using now in there. It's about 50 cents and so forth. The only difference is ours are online, and so they're reporting the information. But we're talking with companies like Chick-fil-A and McDonald's about how to do that for improving their efficiency. So these are the types of things we see out there.
Well, I'm also very interested in keeping manufacturing jobs in the United States and bringing them back. And you wrote in your testimony that America's infrastructure gives us an advantage there. I'd like to hear more about that.
Sure. Well, if you look at everything from our roads to broadband and so forth, and again, these are things that people really use all the time. Whether it's broadband you're wired into your factory or broadband over here, that capability and that growing of that capability allows us to take the big data generated by all of these different sensors, and in some instances, again, it's not just, well, I have a bunch of sensors, but in some instances I've got this phone with this really nice camera, and we have our workforce taking a picture. So now we're combining, right, the workforce that says, oh, this is good, this is bad, taking the picture, that brings it together, integrates the information together, but you've got to get that out, streaming all of the data, and it is a lot of data. And then, of course, the other infrastructure really is the educational infrastructure. If you think about the technology from even 5 or 10 years ago, it's old. So we've got to keep that workforce spun up. Lifelong learning, and that infrastructure needs to be put into place so that today's worker is still viable in 5 or 10 years.
Well, I was going to ask about that because the role of government, and certainly public education is a part of that. But there's also federally funded research, et cetera. So government does have a role to play then, doesn't it?
Oh, definitely. And all the way, again, from the K through 12 that we hear about education and so forth, to our bachelor's students, to our master's and PhDs. I mean, if you take a look at National Science Foundation, I was sponsored at MIT, right, as a National Science Foundation on a project there. A good chunk of our graduates, masters and PhDs in engineering, technology, and in science, are supported by the National Science Foundation. Again, that's something that you don't really see, but they're supported as research assistants. And this is a very important thing to move forward, the entire infrastructure for the nation.
I appreciate that. So I'm concerned because spending plans that we've seen from the Republicans make drastic cuts to many of these things and to programs that directly support manufacturing and innovation, including President Obama's Manufacturing USA initiative. So these cuts, I'm assuming, then could be a barrier to progress.
Yes, I mean, I think that what you have to look at, right, is in the short term, it's fairly easy to make a cut like this and so forth, but really the federal government, we don't have AT&T Bell Labs anymore. We don't have really long-range thinking companies. They're focusing on the here and now, and I don't blame them. All right, the federal government has to step in there and really do some of the longer-range thinking. I guarantee you, China's doing it, Germany's doing it, you name it, other countries are doing it. We need to do it. So in 5 years, in 10 years, we're positioned to continue to move forward. This is really, again, what we really need to be looking at a little bit longer term, and that's what these R&D capabilities are all about that we're talking about.
I appreciate that, and I yield back, Mr. Chairman.
Thank you.
Thank you very much. The gentlelady yields back. The chair now recognizes the gentleman from Illinois, the vice chair of the subcommittee, for 5 minutes.
Thank you, Mr. Chairman. And just to go off what you were saying, sir, I agree with you. I think there's a role for the government in terms of long-term strategic planning that sometimes gets lost in the kind of momentary debates, which is, as we look at a world that changes, whether it's with IoT, whether as we look at autonomous vehicles, which this committee deals with, and all that kind of stuff, we have to have people that are thinking long range and beginning to prepare our workforce for what that future looks like. It doesn't mean the heavy-handed government, but it also means let's consolidate some of these programs we have and try to incorporate a vision, which some of our competitors unfortunately do all too well. I want to thank the chairman for yielding, and I want to thank you all for being here. I'm excited to have two companies represented here that have a strong presence in Illinois, Zebra and OwensIllinois. Zebra's based in Lincolnshire, Illinois, which, now that the economy's expanding, maybe you can build one in my district too, because there's no presence there yet, but we'll take it in Illinois. And OwensIllinois, of course, does have a strong presence in Illinois. Somehow they're headquartered in Mr. Lata's state, but we can talk about that too. And as Mr. Nazmi said, there's an OI facility right in Streeter, Illinois, and in my district. So proud to have you there. You provide good paying jobs. I was able to visit a few years ago and have been very impressed by what I've seen. I'd like to ask the panel, when we're talking about the development of IoT, does that mean that American workers will require new training? And what are companies doing to obtain a skilled workforce? I'd like one or two of you to answer that with your perspectives.
Sure. So, yes, absolutely happy to have our presence in Lincolnshire, and we should talk later.
Yeah, I'm in.
Yeah, with regard to that, worker training, I think that the future we're talking about here isn't going to arrive evenly, right? We're going to see certain areas where we're already seeing IoT drive location technology being used to control drones inside facilities to be able to, in manufacturing plants actually, to be able to detect inventory in a more automated fashion. The ability to have robots deployed in a distribution or a fulfillment center. But what's happening in those environments today is, let me take the robot example, where goods now are taken to the picker. So if you have a human at the end of the day who's doing that picking for those online orders to fulfill those orders, and the goods are being brought to them instead of them walking to the goods. And what does that mean? There's no job taken away. There's just several less miles a day that worker's going to walk. That means there's many more picks per hour that worker can do. And so we're in a world now, and will be for some time, where humans and machines and automation, whether it be physical automation or it be artificial intelligence augmenting the worker, basically a digital assistant.
Well, and I just want to add on to that. If you look at the example, for instance, around Europe, the Germans are very good at manufacturing. They have very low unemployment rate, but they are also embracing this kind of future technology. So we don't have to be scared of the future because it's coming.
Yes.
We just have to figure out how to lead and innovate in that process. Let me, I'll go on. Mr. Pune, when you talk about the Internet of Things, does that create new concerns when it comes to intellectual property? For instance, does the data collected in IoT manufacturing reveal anything proprietary that companies might want to protect?
Yes, sir. I think that one of the things you have to first remember is that the first wave of IoT is being able to take away mundane tasks and make them something that could actually be done more autonomously. I'll give a very simple example. You don't want to watch me parallel park a car. I'm terrible at it. Yeah. But that's a perfect job for a machine to do better than a human, because it's a combination of cameras and geometry. And it'll probably parallel park better than you. But my value add long term isn't parallel parking. So what we want to be able to do as the next wave of economy shows up is to ensure that you've got the appropriate privacy and security baked into many of those, the machines. And there's a whole dedicated work of security being focused on the devices and what's on there. And we have to make sure that there's standards also, because the same type of privacy that applies to people's home, people are worried as to whether Alexa or Siri is always listening to you. Those are the types of things that standards need to be applied, both from the government and the industry working together. And I believe that this is absolutely solvable in the same way that the industry and government work together on standards like common criteria. This will be applied to the new world of IoT in the coming years, we believe.
And Mr. Nazmi, what's the trend when it comes to the cost of deploying IoT? Can you envision a day when the entire manufacturing process, from the procurement of raw materials to the delivery of a finished project, is 100% automated without human intervention?
No, I can't envision a day like that. It still takes human beings on the manufacturing floor to make things happen and make sure things are moving forward. I'll share with you in Streeter, Illinois, it is one of our facilities where we are delivering what we call the factory of the future for the organization, and invite you to come see that at some time that makes sense. But certainly, we're still going to need the capability to have people on the floor that can run machines, be ever present, make sure things are running safely, that productivity continues to move forward. Our innovations are around more flexibility and making sure that we can be more responsive to our customer base. And IoT is another area where we think we can do that as well.
Thank you. Thank you all for being here, and I yield back.
The gentleman yields back, and the chair now recognizes the gentlelady from California for 5 minutes.
Thank you very much, Mr. Chairman. I want to thank the witness panel. This is absolutely fascinating to know what's going on now and what the possibilities are, too, in the future. Digitally connected supply chains have the potential to be an important component of the industrial Internet of Things. Just-in-time manufacturing promises to drive down the need for storing excess inventory and allow suppliers to anticipate and deliver the materials manufacturers will need more quickly. Decentralized ledger technologies like blockchain can make supply chain transactions faster and cheaper by securely connecting manufacturers and suppliers in real time. I'd like to hear from Mr. Pune and Mr. Kerfis, what are your thoughts on technologies such as blockchain and others, and its ability to play a role in IIoT manufacturing and security?
Sure. So that's it's a great set of questions, and the reality is the distributed capability, whether it's blockchain, or any of these other distributed capabilities, these are going to be critical in terms of moving things forward. If I've got a supplier, only one supplier that supplies me with parts, and if I say tomorrow, oh, I need, I was at Toyota, how is it going there? And this is in Kentucky. And, they said, well, great, we've got, every 6 hours we can get, parts from Denso and so forth. We're very lean. We have, very small inventory. You go to Denso, well, how's that working for you? Well, we've got, 2 or 3 months of supply back there because we don't know what they're going to, what they're going to ask us. Now, they're starting to figure out how they're going to ask together, but imagine if instead of one big company, Denso, right, we had a bunch of smaller companies, right, that could supply this. So, yeah, if I need 500 parts, right, as opposed to one company say, can you make 500 parts? I could go to, 100 companies, local companies, mom and pop shops, and say, I need 5 parts. Or how many can you supply? 5, 10, here, there. And all of a sudden, you can bring that together. You not only can get those parts there, and by the way, you could use something like an Uber to make the delivery, right?
Right.
And so the infrastructure, again, back to the infrastructure, it's there to pull it off, right? But now you also have a very resilient supply chain. If one goes down, you don't have to worry about it. Turning that around as well on the educational side, you can take a look at what are these guys doing and, where do they need more training, and let's get them that training. We could even percolate that down into our colleges and into our high school levels so we can deliver the education to the workforce, and we can even start to send the right students in the right direction to really engage them. So lots of stuff distributed, all the way from supply chain of parts, but supply chain of our workforce as well.
Right,
thank you.
That's great. Thank you. Mr. Pune.
Yeah, I think, Congresswoman, this is a very important topic. There's a lot of speculation and euphoria right now about Bitcoin and blockchain. I think the bigger story is the fact that this notion of a subledger, which is really what blockchain about, really transforms the way in which you do commerce at a much more miniature level. And if you think about IoT, it's sort of a miniaturization of this type of device. Now you combine that with commerce, now becoming even more miniature, it has profound implications that could be enormously positive. And that's really, we think, the big story. If there are ways by which manufacturing could get smarter and even potentially more secure, and the commerce that happens, electronic data interchange, all of this could become a lot more efficient and potentially also secure because it's now distributed as opposed to one choke point. Distributed fashions have lots of inherent ways in which you can actually make the system a lot more secure. At the same time, it does require us to take security and privacy even more importantly because of this distributed nature. And that's something we're beginning to do early research on, not just from the industry perspective, but also in academia. But I'm confident that the positive aspects, if you take away the speculative aspects of blockchain, the positive aspects will have a profound implication that's actually, and we need to, as a country, be at the forefront of the research of it, and we don't do it, some of the other countries in the world are.
Oh, good. Well, thank you very much. That was very interesting. Let me go on to something quickly. The Clean Energy Smart Manufacturing Innovation Institute in California has been working to accelerate smart manufacturing throughout the country. Broad collaboration on the integrated tools and systems that are driving smart manufacturing will help reduce the cost of deploying these technologies. These partnerships and collaborations can also facilitate the interoperability of devices and standards. Mr. Kerfis, how can government and industry partnerships help develop tools and practices that will drive smart manufacturing adoption?
Well, so that's a great question, and I think we've already heard about things like
Go ahead.
Oh, I'm sorry. I have heard about things like standards and so forth, but really to help move this forward. The difficulty is, again, you get back to the distribution. There, different people want different, standards and different capabilities and so forth. When you start to bring these these entities together. So, you know, the smart manufacturing team that's, I think, centered in the Los Angeles area, they're actually, and it's not only the big companies, but it's also the so-called small and medium-sized enterprises, the SMEs, that they're bringing together. So they're really bringing everybody together to say, yeah, how does this move forward? How do we do this? And what a lot of the companies are getting is, yeah, I need to release this, because to become more productive, more capable, right, I need to participate in this standard. It's like when I turn my, laptop on, the Wi-Fi, I know I'm going to be online. That's a standard, and that's really where we need to be going with manufacturing. And by the way, we need to do it. We see our, competition overseas doing it in a big way.
Yeah.
So, we've got to be cognizant of that. Thank you.
Well, thank you. This is all very interesting. I know we're out of time, but thank you. You're back.
Thank you very much. The gentlelady yields back, and the chair now recognizes the gentleman from Kentucky for 5 minutes.
Thank you very much. I appreciate this. My background before I got here was in manufacturing. And it wasn't very long ago if somebody from Ford Motor Company wanted to make an order from a supplier, my family was a supplier, you would have a production meeting where they say, we need 1,000 of these parts. A guy would walk out to the plant to look around and with the clipboard or lady and say, okay, we got this much here, this much there. Let's go to the shipping dock, see how much we have there. Because you couldn't always depend on the counts. So then they would call the buyer in our place and say, I need X amount. So they'd walk out on the floor and say, how many do I have? And with a clipboard, and it would just have this whole strain of things. And if you go to an assembly plant, I invite anybody to come to Bowling Green, Kentucky, to go to the Corvette plant and see one of America's great cars made. But what you look for is how phenomenal all of this stuff just comes together and how much effort and timing planning. So if you do it now, you get a production manager says, I need 1,000 parts. Somebody uploads it on the internet. The supplier comes in the morning, downloads it. Everything's barcoded, I assume Zebra, but everything's barcoded so you can depend on the counts. And all of a sudden, it makes a work order. When you ship it, you barcode it. When it goes out, it creates a purchase order, so you get paid for it, and that's distributed through the internet or through the transfers, not necessarily through checks like you used to have to open checks and move forward. So that's happened in the last, since I've been in manufacturing. It wasn't that long ago I started. And it's just phenomenal when we look for it. But I wasn't thinking until I was looking at Mr. Pune's testimony, and working Dr. Kerf is here. My son went to Georgia Tech, so we appreciate having you here today. But I was looking at this security and cybersecurity, because we think about data security. You want your credit card to secure. We've had all these retailers come in and talk about. But really, if you put everything online and everything's Internet of Things in your manufacturing facility, is there a cyber attack? Could that shut down an assembly plant? So in your testimony, you talked about the importance of edge systems like Internet of Things gateways. And why you talk about securing the production lines, and not necessarily, I don't think it's just from attack you were talking about, but just if you could throw that in as well. And the importance of cyber hygiene, and can you describe how this would provide reasonable level of security?
Yeah, happy to, and I think the focus on security is a very good one. And I think just the same way that if you thought about various different eras of computing, sir, mainframe to client server to mobile cloud, this notion of security is becoming more and more profound, because if there's one thing that's true, even though security is getting a lot of spending in software, the bad guys, there's more attacks than there's actually investment even in security companies. So we have got to take this seriously. And the good news is that countries like the United States, Israel have been at the forefront of security spending, and we want to take that seriously. So the way in which we think about IoT is, as these devices get miniature, first off, you want to make sure the operating system that's on those devices are as secure as possible. And I think we've learned a lot as the new operating systems that are post-PC have gotten more mature. And with every generation, they're getting better and better. iOS is a good example of that, and the iPhone being more secure than the first examples of the PC. And those will play down into the miniature devices. Secondly, you want to have control points that dislocate just these devices into what's called a gateway. So a gateway is just a consolidated form of many of these, so that you have one place rather than multiple places where much of it gets consolidated. Dell manufactures some of these gateways. You got to make sure those are secure. And then as they talk to other systems, for example, a data center or cloud, that connection needs to be secure. And there's techniques like microsegmentation. Ways in which you authenticate into those systems using multi-factor authentication. And these are all technical terms, but for the folks who are savvy in security, we're educating more and more of them. And then finally, for the common person, as I described earlier, you want to be able to educate them on some very basic principles of cyber hygiene, especially as it relates to their access to systems. Having a two-factor authentication is something that everybody should know about. It's not just your username, but some other factor. Maybe it's your birth date. Maybe it's your mother's maiden name. And setting up your system so that you have that and refreshing that allows less possibilities that your consumer accounts could get hacked. the same way that the enterprise is dealing with it. These are just a few of the many principles of cybersecurity. We've written a white paper about this, and it's a topic that all of us in the industry, there shouldn't be competing agendas here. We need to work together to ensure the security of the IoT systems.
A quick question. I appreciate Mr. Massey. He was talking about glass and going from 91 to 93%. I'm aluminum foundry die casting, and you said it's sometimes more of an art than science. And I remember saying that in a meeting, and a guy goes, well, all science was an art at one time, and how you perfect it. So I only have a few seconds, but when these first come out, a whole industry's created and everybody's buying these, all of a sudden you get saturation and sustainable and improvement. But there's a whole opportunity, the whole world of people in Silicon Valley, all over America, to go in and redo these plants and redo these facilities. And I don't have much time left, but anybody want to talk about just what transformation and what economy that could create by people going through and refurbishing their plants?
I'll just really quickly fire it off because we see it across the board. We work with a lot of different companies. The opportunity is tremendous, whether they're the small or the medium or the large companies, because again, the kids now, they program these things, and so they're in there, hey, look, we can do this. Barcode readers? Oh, we don't need barcode. I mean, this is the barcode reader now and so forth. And so they're really implementing it. And so it does allow you to do these types of implementation. But back to, Mr. Punen's point, we've got to make sure that we're very secure about this. So, and again, in our classes, whether it's high school or junior college, whatever, we now see that a lot of this type of thing, we're just doing good hygiene. For example, do not plug this into, just any old computer. I go to a machine shop, $1 million machine tool recharging my phone, which could have a virus on it, right? And so these are the types of things that we really have to start teaching them and so forth, but the opportunity is tremendous.
Thank you for your indulgence, Mr.
Representative Guthrie, just one other point, if I may. There's a whole suite of capabilities that we're starting to bring to these enterprise devices. We actually call it Mobility DNA, but the idea is taking the standard operating system that we might be using, Android by way of example, and layering a whole host of enterprise-centric security on top. So, and we're working closely actually with VMware on this sort of thing. So as these devices, these internet endpoints are deployed in these manufacturing facilities, being able to make it secure all the way at the device level. So we have a network of secure devices instead of just trying to secure the network. And that's an investment we're making to basically serve enterprise in an even more secure way than we might find in traditional consumer devices. That, and the last thing I would just end on the word silos. I think there's tremendous opportunity to bring silos down across what many of my colleagues here spoke about, from farm to fork, if you will. So for being able to share data from where that seed was planted in the farm field and be able to carry that data all the way through to optimize the harvest, that out to the transportation carriers for just-in-time delivery, and then ultimately getting to a retail location where we can all enjoy that in a much more efficient way and in a way that allows us to, in a more cost-effective way, to reach more people. So I think that the data silo opportunity is tremendous as we start to collect more and more data across all the different elements of the supply chain. Thank you.
Thank you very much. I appreciate the indulgence.
Thank you. The gentleman from Pennsylvania is recognized for 5 minutes.
Thank you, Mr. Chair. Dr. Kurfus, I wanted to focus on something that you had provided in your written testimony, not just ask you, but ask the rest of the panel for their feedback as well. There's no doubt IoT and manufacturing will help to grow our manufacturing operations and will generate new and higher paying jobs. However, those jobs will be filled by individuals that are highly trained. Furthermore, those individuals will need to be continuously trained, and that's what I want to focus on. In the latest and state-of-the-art technologies to keep U.S. manufacturing operations at the forefront of this rapidly advancing technology wave. Thus, a culture of lifelong learning must be instilled and supported in our workforce. If you look at our high schools and STEM schools and trade schools for 18 and 19-year-olds, I am struck by the opportunities that might be available to incorporate more of this lifelong learning culture into curriculum at an earlier age so that it is not incumbent upon a company in order to do that. And when you look at a company of 20, 30 people, even startups or two, 3 individuals, it's just simply not sustainable to offer that type of learning and sort of up-to-date type education that's required in order to keep a well-trained workforce. I've already spoken too long. Share with me what you think the right kind of learning platforms are in order for our country to be a leader for the next 20 and 30 years so that these are not jobs that are not remaining in the U.S.?
Sure. So really quickly, the first thing is, I can tell you, we have turbine blade production. We do a lot of work in turbine blade production. So we have turbine blade production machines. We're doing research and so forth. And typically, you need about 15, 20 years of experience before we turn you loose on those in production operations. We have developed gaming interfaces, high-performance computing that can really, it just pounds that problem to dust. And they're gaming interfaces, and we have high school kids who are now programming these types of machines and so forth. So it's a whole different way of learning. And as I mentioned before, we can even take a look at, who is, really excelling. People think, oh, engineering, I've got to be a super genius. Well, you have to be fairly good at math and so forth, but if we can start to really identify those students early on and start to work them forward. They don't necessarily have to go into engineering. Maybe they're going to go into the shops and so forth and get the right type of training. But it's a two-way street. So the infrastructure is coming into place. We have a number of these different, if again, you look at Manufacturing USA, these centers that are working with the local and in particular the community colleges, the associate's degrees and so forth, where they're saying, yeah, what is the next generation that we need to be moving forward, and let's work that into the curriculum. And that's not only for the two-year degrees, but for the continuous learning. And then we also see a lot of the professional societies that they have a lot of curriculum developed that's deployable, whether it's on the web or interactive and so forth. So a lot of that technology is moving out. But I agree, you have got to build it in. Universities, I think, have done a good job with lifelong learning. We now have to start to propagate that down into the K through 12. It's getting there, but once it's there, I think the access for those students and for that workforce is available. And it also does respond very quickly to the needs of the workforce and the needs of the market.
Right. Mr.
I would just briefly add, this topic is personally very much a topic of passion for me, sir. I came to this country as an immigrant, and now I'm a U.S. citizen, partly because the United States has the best universities. I studied my computer science at Dartmouth College. I did my MBA at Harvard University, at Harvard Business School, and I hope that this continues to be the country with the best education in the world. The education has now changed. Today, my kids who live in Los Altos, California, are learning through Khan Academy. YouTube has completely transformed education, and it's not just for kids.
Right.
You can get a how-to or learn-to anywhere, any place in 15, 20-minute TED Talk types of videos, and we encourage our workers to constantly be in that learning mode. And the good news is the internet makes that possible. And it's almost like, upending the classroom, where learning is happening at home in the evenings, and the classroom becomes a discussion forum. That's the new fashion of what we're doing. I think the other part that is incumbent on all of us as leaders is to mentor others. As much has been given to us, we've got to give back to the next generation. And I encourage all of us, I know many of our colleagues here do the same, it's our job to mentor the next generation. And as we do that, both the combination of STEM and mentoring will make the next generation ready.
That's interesting. So it may be technology that enables us to teach technology in a
Exactly, sir. That's what we hope.
Anyone else?
From a manufacturing company perspective, we are investing in our local high schools and STEM programs to help the younger generation get interested in science and technology. We're also working with local universities to make sure there's an interest as well. So I personally believe helping workers, obviously continuous learning, lifelong learning. There's also an aspect of a company helping our employees be lifetime employable through those kinds of ideas as well.
I appreciate your feedback. I yield back.
Gentleman yields back. The gentleman from South Carolina is recognized for 5 minutes.
Thank you, Mr. Chairman. Siri. Hey, Siri. I use that as an example in that these devices are always listening, right? Whether you have an Echo in your home or some similar device, whether manufacturing has those devices that, as you say, are all interconnected, or whether you as an individual have a smart TV and the internet rumors, true or not, that TV is spying on you and sharing that information. As we move forward with technology, we have a refrigerator that notices that my milk is low and asks me if I want to order milk, and I do. Sends a signal to the grocery store, milk, bread, and other things I may need delivered to my home by a autonomous vehicle, right? So I consider myself a conservative. There's nobody in this room that would say I'm not a conservative. But I actually take it another step further. I'm a conservatarian. in that I have a libertarian streak in me that it's my information, and I own it. But in this scenario that I laid out, who actually controls that data and who owns that data? And at some point, is the government getting that data? And what do they do with it? Now, data sharing and my buying habits and what Amazon is sending me through emails or pop-ups that because they have watched my buying habits and they're recommending certain things, that benefits me. I get all that. But I can tell you the constituents in the 3rd District of South Carolina are concerned about who has that information, what they're doing with it, and ultimately does it get in the government's hands without any sort of Fourth Amendment protection, so to speak. So I would just love to, I know, Mr. Pune, you were talking about some of that earlier. I'd just like to expound on that. Who owns that data, and how can I assure my constituents that that data is not going to be used wrongly? And then I'd also like to get back out on that tangent because you've got proprietary information in corporations, and we all know that China got the plans for the F-35. China has gotten plans for a lot of the military components with the best safeguards of cybersecurity in place by our government, right? Who has access to all of y'all to create those platforms for security. So I would like to talk about not only individual privacy and data ownership, but also how do we keep China from, or a Chinese company, and I'm not just singling China out, but from going to BMW or a Magna or some sort of manufacturer in the 3rd District and getting proprietary information as well and creating a competing product.
Yeah, very briefly, and then allow time for my other colleagues too. This is a very hard topic. I would be smug if I said we have all the answers today. This is going to require continued innovation and collaboration with the government. I would say there's a family of problems that are related to predictive maintenance of machines that are positive. For example, if the refrigerator or the washing machine is about to, decrypt it and you need someone to come and help you on that, that's a family of problems that people are probably less concerned. The data on that machine probably needs to be encrypted. But as soon as you have things that are voice recognition, camera-related, privacy concerns going on, and we encourage consumers, certainly enterprises also, to be extremely cautious with those. So you can turn the camera off on your TV. You can certainly unplug Alexa where you need to and get appropriate cautions as to how you handle these consumer devices.
But that smart TV's monitoring all of your viewing habits.
Exactly. So this is going to be one of those places where a combination of encryption, a combination of technologies, and I'm with you, consumer privacy, the consumer owns that data, the way in which they interact with enterprises. Most of our focus has been on the enterprise usage of this, but the consumer part of it is a huge problem that needs to be solved together. And there's no easy answer for much of this because we're just beginning to scratch the surface of many of the topics that are way out there.
In the essence of time, we know China took the plans for the F-35, so to speak, and government was involved. How do private industry, how can they have some assurance that their proprietary information is shielded from their competitors?
Yeah, we're seeing the shift from assuming that we can prevent an enemy, if you will, from getting in to being able to detect that as quickly as possible. And so if you think about what is your mitigation plan if you assume a thesis of you will prevent attack from occurring, you have a very different outcome in that strategy and that plan than if you assume that you will not be able to prevent an attack. And so now your strategy is going to be to detect that as quickly as possible, to shut down that intrusion, and then to take the corrective actions from that point forward, but detecting that as soon as possible. So going from protecting to detecting, and then taking a countermeasure as quickly as possible in every sense of that word, I think is a shift we're seeing right now. It's no longer, as you pointed out, the best resources on the planet in some instances cannot protect that attack from occurring. So let's focus more on leveraging all the technologies we spoke about here, machine learning, artificial intelligence, technologies like deep packet inspection of packets on the network to be able to detect that event is occurring. With regard to in-home, I think similarly we're going to see technology that's been used for a while in the network space called deep packet inspection, where why not have a single source of truth of the information that's leaving my home? What products are sharing what information with whom? And imagine if I had a dashboard that I could go to a portal on a web page in my home, And I can see, well, I shut that TV, I don't want that camera on that TV sharing information. Is in fact that data going out over my network or not? And those kinds of dashboards, so that we can have enjoy, all of us, the convenience associated with sharing that information, but have the integrity and the single source of truth to understand what actually is being shared. And I agree with the number of devices and the prolific nature of this, that thinking that we're going to be able to control that because we were told it works a certain way is not going to be sufficient. So
I guess my constituents would say, is Big Brother going to call me or send me a notice and say that your thermostat was set on 72 when you left the house today and you've overutilized your allotment of electricity for the day? Yeah. You see where I'm saying?
I do.
And I think be going, and it's a true concern.
I think the best answer to that is to use all of the mechanisms I just mentioned and more to come to ensure that that's your option, right? You're informed enough to it's your choice to share that information for a benefit gained.
I'm way over time, Mr. Chairman. Thanks for the leniency.
Thank you very much. The chair now recognizes the gentleman from Texas for 5 minutes.
Thank you, Mr. Chairman. I thank our witnesses for being here. Sorry we have other committees, Energy Committee upstairs, and so I'm jumping back and forth. When I first saw the hearing, and that's why I appreciate this subcommittee, the Internet of Things, I thought, what in the devil is the Internet of Things? I cleaned up my speech after the president didn't. But what is it? And thank goodness I have young staff to explain to me. I'm glad you're having the hearing because it makes some of us who don't typically live with these things shed light on different aspects of the smart manufacturing and the Internet of Things. One of our witnesses mentioned manufacturing is one of the sectors that is investing the most in IoT. I have a district that's predominantly petrochemical refineries, chemical plants, extraction, and I know they're looking for every way they can using technology to both to produce their products safely or cleaner. And doing more smart manufacturing can make operations both environmental, safer, and more efficient. But Congress needs to do more to prepare our workforce for those changing needs in manufacturers. Mr. Kerfis, you mentioned in your testimony the importance of instilling a culture of lifelong learning and of helping to train our manufacturing workforce in the data science and IT skills that workers need. Some people that need job training the most are the unemployed, and one of the biggest obstacles they face is getting into that technical training is the cost of it. Can you elaborate on possible ways Congress can help this technical training being made more affordable, as well as help support a culture of lifelong learning broadly?
Sure, I'm very happy to do that, Congressman. In terms of, I know that there are a lot of initiatives that are really supporting the community colleges. These are the two-year colleges and so forth. They're very cost-effective for the training of the workforce and so forth, and there's a lot of leveraging that goes on there. We heard about some of the online courses, that are available today, even via YouTube and so forth. And actually, at least our younger generation, they learn and they think in a different way, right? So, when I was a student, I might have had one book to look at or maybe two books to look at. Now they go out there and they get, 10, 20, 30 different examples and so forth. So really not only just saying, yes, we could make sure that we can, support the community colleges and some of the professional societies that have, these types of course offering, technical training offering, but also the ability to basically say, yeah, let's make sure that we're starting to leverage some of these new approaches to teaching and so forth, and that we understand that they're out there so that it comes out there very quickly. And by the way, these are also very important, not just because they're lower cost, but they're very nimble. They can respond quickly to new technology as it comes along. So, if you have some YouTube videos out there, you can learn anything from fixing, a faucet, all the way, to, hey, let's go do a calculus problem, right? But as new technology comes along, it's amazing, right? You can go to YouTube, you can go to some of these different courses, even MOOCs, these massively online, courses and so forth that some institutions offer for free, right? And so how do we promote that? How do we then, once you have that, I think the next key thing is certification. Oh, yes, you are certified in that course so that when they go to your company, and by the way, it's interesting, when I think of people think manufacturing, make a car, those petrochemical plants are enormous manufacturers within the United States. And so how do we know, right, when that company says, yeah, I want to hire somebody, that, yeah, this person has the right credentials? It's great that they have a degree from, let's say, a Georgia Tech, but what about just some of the smaller credentials that are going along? So a lot of that credentialing, again, getting back to some of the standards that we're looking at.
Well, I appreciate that. I actually have a community college in our area who partners with the petrochemical industry, San Jacinto College in East Harris County, Lee College in Baytown, because of the dominance of that industry. And I've been out there, and they're doing, and a number of my other community colleges in our areas developing the same thing, because you just don't go get your associates or your bachelor's or anything. You need to continue to look at what's new. And I was there on campus one time, and a young man had about 3 different certifications, and he was getting offers of over $150,000 at a Shell refinery or a LyondellBasell refinery or chemical plants. So it's a way that but you have to continue to keep up with your industry, and that's what community colleges can do. So I appreciate it, Mr. Chairman. Thank you for the time.
Well, thank you very much. The gentleman yields back. The chair now recognizes the gentleman from Indiana for 5 minutes.
Thank you, Mr. Chairman. Mr. Pune, I'm going to primarily talk with you and some of the others about security. We're mostly, it seems to me, when we're talking about security, we're talking about software and other and access and things like that, passwords and all of that. But you probably saw in the news recently that in some areas across the country there were some communities and police departments that took down their security cameras because of concerns about where that product was made, and it was made overseas. And so there was some question, not about that it was connected to the internet, but the actual hardware itself and whether that was compromised. What are we doing? And I know there's some things I know what we do at the federal government level to ensure, for example, that chips that are used in Defense Department products are not compromised, so to speak. But worldwide, and even in the U.S., some people estimate as many as 10 to 15% of computer, the hardware, like the silicon chips, are actually counterfeit. That's an area I think we should also look at. What are we doing there?
I think it's absolutely wise, sir. I think that when you think about security, it absolutely is in all of those layers. You need a multi-layered, whether it's the hardware, whether it's the software, whether it's the service, whether it's the people. And listen, capitalism works only if the entire world is a level playing field. And when some countries are not necessarily playing by that, I think it's absolutely the wise policy, whether it's the FBI, whether it's the appropriate agencies, to ensure that our products, whether they're bought from a foreign party, don't have embedded components, hardware or others, that could potentially compromise the security. So
I can tell you probably know, and I know this myself, sometimes it takes an electron microscope and people that understand to detect these problems with chips and stuff.
Yeah, absolutely.
I mean, it's pretty sophisticated stuff.
And that there's absolutely that evidence of that happening. I think the appropriate scrutiny. I'm not a protectionist in terms of the way in which we think about the economy. We do believe in free market, but it has to be one where the level playing field. So many of the governments that have been focused on this, certainly the United States and Israel, that have had this, have got a very good way of looking at the ways in which many foreign governments are building technologies. And without naming certain countries, we've got to continue that diligence, because whether it's the camera technology, whether it's voice recognition, the types of things that could leave us vulnerable, we've got to make sure we've got the most protection. We work very closely with both the industry and the government, with agencies, to ensure that happens. That's probably a topic we haven't talked about. I'm very glad that this committee is focusing a lot on security. Security is probably one of the key topics in this entire topic of IoT that needs even more and more focus.
Yeah, because, I mean, it is a global marketplace, and I'm in favor of that. I'm a free market person also. Well, I think we all are. But we also, from our job's perspective as members of Congress, we have to consider national security-related risks and portals of entry into our that can, and the biggest port of entry that we have is our people using connected devices, maybe even at their homes, right? For example, say someone works, I'll just say they work at the NSA and they deal with classified material every day that we don't want people to know about. But when they go home, they have all their devices at home are all connected, and who knows who's listening. And and even though they're not supposed to, what if they're just, pontificating even themselves about the day's activities? I mean, it's hard to know. So I have pretty significant concerns about on the hardware side. I mean, because once we are able to mitigate other things, people are smart.
Yeah.
They're going to be one step. You're already too late when the hardware itself is compromised. Does that make
I was
sense?
just going to add, absolutely does make sense, Congressman. If I could add, if I could suggest we could break the problem down to two components. One is around the counterfeit side of things. So if these are counterfeit chips or that are made overseas, copying our technology, and as you pointed out, you need some very sophisticated technology to check that. But what I would say is that actually IoT is a mechanism for auditing that, because if I'm and we're seeing this occur today, if I'm a manufacturer, a semiconductor manufacturer of those chips, I can have each one of those chips report back when they connect as basically a pulse to say that that device is present. And if I see that coming from more devices than I've shipped, I've got an indicator that there's an alternate end around from a supply chain perspective. Someone else is injecting, if you will, these chips into the supply chain that aren't coming from my factory. So it's sort of an IoT-connected auditing mechanism. I think that represents one level of certainly compromises economics, but is a little bit lower on the threat level compared to, as you were suggesting, information that's being sent, that's actually being captured. We don't know it. The example you gave around the device in the home connecting back to the network, or a video camera in a municipality that's sending information back to individuals that we don't want it to go to. And there I think we are, a number of companies working on networking technology that can detect if information is being sent that is different than what we intended to be sent. And I think if we can audit the network, if you will, the pipe of data that's being sent to see what's actually being sent versus what we've authorized, and at the same time, we can continue to invest and drive in IoT. So all of our devices, for instance, that are connected out in the field can connect back. We can literally count the devices we've shipped. We can count the devices we see. And if there's more devices we see than we've shipped, then something else is going on. So those, I think, are perhaps two ways to look at it. Certainly a complicated problem, as our colleagues have pointed out, but a food for thought, perhaps.
Okay, thank you. I yield back, Mr. Chairman.
Gentleman yields back. The gentleman from California is recognized for 5 minutes.
Thank you, Chairman Lada and Ranking Member Schakowsky, for calling this hearing. As a former small business owner myself, I know that a business that's not growing and evolving is a business that is not succeeding. As an engineer, I've studied the rise and proliferation of connected devices and for their potential to help businesses and government evolve and better serve their consumers and constituents. For example, a company in my district that testified last June in this hearing on the Internet of Things, LaRue Electronics, uses connected microphones and sensors to help protect property and also help law enforcement detect and rapidly respond to gunshots. On the public service side, the Internet of Things technology has helped local governments and firefighters monitor and prevent and fight back firefighters in Southern California, for example. Recently, the House passed my amendment to study the use of drones to detect and fight wildfires. However, I also know that as with any rapid growing technology, we must encourage innovation smartly, responsibly, and with our eyes wide open. We're constantly learning that virtually any connection can be hacked, so cybersecurity is an area that businesses and government will have to pay extremely close attention to and invest a lot of resources. Another issue that we need to hold our businesses to a high standard on is workforce preparedness. As our companies evolve, our workforce must necessarily evolve as well. Ideally, this evolution will come in the form of education and retraining. This was an important issue that I brought up during our markup of the Self-Drive Act, and it's an important issue in every environment. For example, Southern California happens to be, I was told when I got elected to Congress, I was reminded that Southern California is the largest manufacturing area in the entire country. I was pleased and surprised to hear that. So this is an issue that not only is important to my district, but important to one of the biggest economies in the world, which is California. My first question is to Dr. Kerfis. You have the advantage of a bird's eye view of the industrial Internet of Things through your work with a variety of companies. So can you describe briefly what practices you've seen that help workers adapt to and learn how to better use new technologies?
Sure, that's it's relatively straightforward. Some of the practices that are out there actually get to some of the discussions we've had about just hygiene, right? You know, don't plug your phone, you know, into the $1 million machine tool out there because it might have a virus on it and so forth. But some of the other practices really go along the lines of, you know, understanding what people are comfortable with, you know, in terms of using and so forth, and letting them make use of that technology, you know, in place. As I said before, we actually have developed some software where you're doing a Pokemon type of program where, you know, you're looking for the guy to try and capture, but that guy you're trying to capture is a flaw in your production cycle and so forth, and you capture those. So you actually start to bring these together. The Internet of Things, people are very comfortable in general. It just doesn't matter who you are. People have the smartphones now, and they're very comfortable using it. And so the idea really is, yeah, can you bring that comfort together so that, you know, they make use of it in a very easy and natural way. So that's one of the things. The other thing, again, and we've heard from several companies here, again, just continuous learning, you know, to make it easy, to make it, you know, rewarded, to provide the time so that the people in the plant can do some learning. And we're not talking hours and hours of time. Typically, it's just, yeah, just take a look at this thing, you know, we can track your progress and so forth, and, you know, making sure that they're up to speed on what a company needs to have them up to speed on, whatever that might be. Today it's going to be, and I think, again, you know, coming out of California, you realize this, whatever's going on today may not make a whole lot of difference tomorrow in terms of technology. That's how rapidly things are changing.
It's interesting that you described the example of the cell phone and how that could interfere with the opportunity to, unfortunately, have an infiltration in your system. I learned, again, through this committee, is one of the subcommittees on health, is that some hospitals and a lot of people now realize that infections, if you're going to get an infection, you're probably going to get it at a hospital more than anywhere else, that it wasn't some incredibly expensive process to bring down the infection rate in hospitals other than having the discipline of everybody washing their hands at every opportunity. Something as simple as soap. But what I'm getting at is, I think it's important for us to teach the next generation of workforce that even though they find these things to be so darn convenient and think that it's the answer to everything, it actually, if not handled properly with simple measures, you could actually cause a disaster, a catastrophe that is unintended. So I think it's important for us to realize that sometimes the answers are complicated, sometimes the answers are really simple about basic discipline. Thank you very much, and I yield back my time.
Thank you very much. The gentleman yields back. The chair now recognizes the gentleman from Florida for 5 minutes.
Thank you, Mr. Chairman. I appreciate it. And thanks for the testimony. I was at the VA committee, the Joint VA Committee hearing, so I apologize for being late. I have a couple questions. The first one for Mr. Cooley. In your testimony, you state that industrial IoT-based solutions are allowing companies to create jobs. One of the big concerns we're facing is automation replacing jobs. So can you please explain to us how these solutions help create jobs?
Sure. Yeah, I think there's sort of a micro and a macro view on that. The micro one I mentioned a little bit earlier around machines working with workers to help them get their jobs done more effectively. And I think when we think about that, we have a tendency to think of the brawn side of that, meaning that the physical movement of goods, and that's for sure part of it. The other part of it is the brain or the intelligence or an assistant that can work along a worker. So we mentioned wearable technology, augmented reality, being able to put information right up in front of the user. And as this starts to assist you to actually create more job satisfaction, a better work environment, it also, in addition to increasing quality and having benefit to the bottom line, it reduces the cost of getting that job done. And so if I shift from that micro perspective over to macro, as we reduce the cost of getting that job done, we become more competitive on a global basis, thereby bringing jobs back in. So if we look at any one instance, we could point to, well, if we're reducing the cost of labor, that some might say that's reducing the number of jobs. I would say it's increasing the efficiency of an individual, and thereby increasing the efficiency of that individual. It has the macro effect of making us more competitive on a global stage. And I think that we're starting, I mean, it's happening already. We're starting to see that bear itself out. The other thing that we're starting to see with the on-demand economy that we mentioned earlier is the peaks are getting peakier, if you will. If you look at the number of shipments that are happening from manufacturing facilities or from fulfillment centers in November to January timeframe, in some cases, we see this in the headlines, transportation carriers, retailers are doubling or tripling their workforce to be able to handle that peak demand. And so when you bring that influx of workers in, if it takes 2 weeks to train somebody how to do that job, you're a third of the way through that peak cycle. So leveraging this technology so that someone can be functional and up and running in an hour and be as skilled or as capable as someone that's been doing it for several weeks also becomes very important. So I think if we view it that way and look at the bigger picture over the longer time horizon, there's early indicators that what I just described is starting to happen, and I think we should lean in and accelerate to take advantage of that for the country. Thanks.
Thank you. Good answer. In your testimony, Mr. Nazmi, you note that and I quote, the cost to achieve a full deployment of IoT throughout an enterprise can be quite daunting, and suggest that the lowering those costs would help ensure the deployment of the IoT. What are some of the ways policy changes could help?
Certainly, looking at ways to reduce the cost per unit of a sensor or technology can help spur investment into IoT. And it's not just one thing. It's sensors, it's PLCs, it's storage, it's systems, it's investment in programming and those kinds of things. So certainly looking at ways that we can spur innovation, get products produced at a lower price than manufacturing companies can consume and deploy at a lower cost point, especially in a business like ours, which is very capital intensive, is going to be incredibly helpful to move IoT forward.
Very good. Thank you. Mr. Chairman, I appreciate you holding this hearing. Very informative, and I'll yield back the balance of my time.
Thank you very much. The gentleman yields back the balance of his time, and seeing that there are no further members wishing to ask questions, I want to again thank all of our witnesses for your great testimony today. Before we conclude, I would like to include the following document to be submitted for the record by unanimous consent. A letter from the Electronic Privacy Information Center, and hearing no objection, that letter is part of the record. Pursuant to committee rules, I remind members that they have 10 business days to submit additional questions for the record, and I ask the witnesses to submit the response within 10 business days upon receipt of the questions. And without any objection, the committee will stand adjourned. Thank you very much.